So, what if I told you that our entire understanding of the universe is basically a historical accident? What if, a couple hundred years ago, scientists took a left turn when they could have gone right, sending physics down a completely different road? Well, today, we're going to explore that lost timeline, a parallel scientific history where reality isn't random at all. A universe that works less like a game of dice and more like a crazy cosmic pinball machine.
And this quote, man, it just nails it. It suggests that one single tiny observation, something that was finally seen in 2020 with, get this, just a laser and some soap film, could have completely rewritten the last 2 centuries of science technology and yeah, even our whole philosophy on what it means to be here.
Okay, here's the big idea in a nutshell. We live in timeline A. This is the world of quantum mechanics, where everything is governed by probability and chance. Einstein, famously, he hated this, saying God does not play dice. But what if there's a timeline B, a lost timeline, where reality is deterministic? It's chaotic, sure, incredibly complex, but ultimately, it's knowable. In that universe, Einstein was right all along. God doesn't play dice, he plays pinball. So how did we end up on our path? Well, you can trace it all the way back to 1801 and the famous double-slit experiment. First, it showed light acts like a wave, which was weird enough. But when they did it with single electrons, things got truly bizarre. It forced us to accept this idea called the Copenhagen interpretation, which basically says a particle isn't in any single place. It's just a fuzzy probability cloud until the moment we look at it. And that one strange, mind-bending result became the bedrock of our reality. But what if another, totally different kind of weirdness had been discovered first? One that didn't point towards random uncertainty, but towards a hidden, complex order. And that brings us to the key phenomenon that defines this whole lost timeline. You know, in school, we all learn that waves basically do one of 2 things. They're either ballistic, traveling in a straight line like a laser pointer, or they're diffusive, scattering all over the place like light hitting a foggy window. But it turns out there's a secret third category, a missing link that could have changed everything, something called branched flow. So, what on earth is branched flow? Okay, imagine a wave moving through a medium that has gentle, random bumps. Think of it like a landscape with microscopic hills and valleys. Now, instead of just scattering the wave randomly, these little bumps act like a million tiny lenses. They focus the wave's energy into these intense lightning bolt-like channels called caustics. And these branches can stay focused and powerful for way longer than you'd expect. And this is just so wild. It shows you how close we were to finding this all along. In 2020, scientists finally did the experiment. They just shone a laser into a simple soap film, and there it was. For the very first time, they saw light itself form this beautiful, intricate, tree-like network. The experiment that could have kicked off an entirely different reality was finally done about 200 years too late. But hold on, because it gets even crazier. In this alternate timeline, they would have also discovered something they call superwires. These are these incredible, stable channels that can form in just the right kind of material. A wave gets locked into one of these paths, and it can just flow forever, without ever spreading out or scattering. It's like a ghost pipe, held together not by walls, but by the pure physics of the system itself. So, okay, we have branched flow, we have these sci-fi superwires. What does a universe built on this stuff actually look like? Well, it starts by completely tearing down and rebuilding the most fundamental thing there is, the atom. See, in our world, the atom is kind of like a ghost. That electron isn't really a tiny ball orbiting a nucleus. Nope, it's a probability cloud. We literally can't say where it is, only where it's likely to be. Its position is just fundamentally, deeply uncertain right up until the moment we measure. Now, contrast that with the pinball atom. In that universe, the electron is a real particle. It has a definite location at all times. It's just riding on one of those stable superwire tracks, a really complex but totally deterministic resonant path around the nucleus. It's not a cloud of chance. It's a particle on a predictable, albeit wild, roller coaster. This table just lays it all out. And the difference is wow. Our world's foundational mystery was the double-slit experiment. Theirs was branched flow. For us, uncertainty is a fundamental property of reality. For them, it's just a sign you don't have enough information. Our atom is a fuzzy probability cloud. Theirs is built on resonant superwires. And maybe the most profound difference of all, their vacuum, space itself, isn't empty. It's a textured medium that guides everything that moves through it.
All right, so a totally different physics is naturally going to lead to a completely different set of technologies, right? So what could the engineers of the pinball universe build that we can only sit here and dream about?
Let's start with a really simple question that actually points to a huge roadblock in our world. Why do we need these giant, powerful X-ray or MRI machines to see inside ourselves? I mean, why can't we just use light?
The answer is really simple. Scattering. To a beam of light, human tissue is basically like a super dense fog. The instant light goes in, it bounces off millions of cells and scatters in every direction, completely scrambling any image. For us, that's a fundamental dead end.
But in Timeline B, scattering isn't a dead end. It's a code that can be cracked. They master a technique we're only just beginning to play with, called wavefront shaping. Basically, they can pre-scramble a beam of light in just the right way so that when it enters the body, it unscrambles itself to form a perfect, tiny focus point deep inside. And that leads to their killer app, the optical biopsy, a handheld device you just point at someone and it lets you see a tumor with microscopic resolution. No scalpels, no radiation, no problem.
And these consequences, they don't just stay on the tiny microscopic level. No, this alternate physics scales all the way up, from the cells in our bodies to the very structure of the cosmos itself, and it offers a solution to one of our biggest headaches. So, in our timeline, we have this massive cosmic mystery. When we look out at galaxies, we see them spinning so fast that the gravity from all the stars and gas we can see shouldn't be nearly enough to hold them together. They should just fly apart. To fix this, we had to invent an idea called dark matter, an invisible, totally undetectable substance that we now think makes up a whopping 85% of all the mass in the universe.
The physicists in Timeline B, they have a much simpler, more elegant solution. See, for them, space isn't empty. It's a textured vacuum, a medium with subtle little variations in its density, kind of like currents in an ocean. And those variations create what's called a refractive index, a property that can bend not just light, but gravity itself.
So that halo of missing mass that we're desperately searching for around galaxies? In their world, it's just a cosmic mirage. It's a caustic halo, an optical illusion created by the branched flow of light and gravity moving through the textured fabric of space. The extra gravity isn't from missing stuff. It's an artifact of space itself acting like a lens. No dark matter needed. Problem solved.
And this brings us to the most profound shift of all, because the way we understand physics completely shapes how we see ourselves and our place in the universe. You change the science, you change the entire philosophy.
Our quantum world tells us that reality is fundamentally random at its core. That's indeterminism. It tells us that what we see actually depends on the act of us looking. The pinball universe, though, is different. It's a world of stochastic determinism, which is a fancy way of saying that while it's incredibly complex and might look random on the surface, everything is actually following a definite path. This creates a belief in an objective, knowable reality and a feeling of deep, fundamental interconnectedness.
This famous quote just perfectly sums up the kind of philosophical realism that Timeline B never lost. I mean, in our world, there's a serious, legitimate debate among physicists about whether the moon even has a definite position when nobody is observing it. In their world, that question is just absurd. Of course it does.
Look, we can't turn back the clock. We are products of Timeline A, for better or worse. But with these brand new discoveries of branched flow, it almost feels like we're finally getting a peek at that path not taken. We're learning that what we once dismissed as just random noise is actually a rich, complex landscape that we can learn to navigate. The universe might not be a game of dice after all. It might just be a pinball machine. And maybe, just maybe, we're finally starting to learn how to play.